All right, so we're going to talk here. We're talking about, we have a piece of metal here that is about 200 grams. All right, and we're going to set it on this hot plate, which is very hot. And we have 200 milliliters of water, which is also 200 grams. So the objects have the same amount of mass. And since we're sitting on the same hot plate, they are getting the same amount of heat or thermal energy into each of them. All right, now if we leave them on there for about the same amount of time, we would expect both of them to have about the same temperature because they have the same mass and they are being stuck on the hot plate. All right, and if we leave them there for the same length of time, same amount of heat energy going into them, we would expect their temperature to change by the same amount. All right. However, in real life, it turns out this doesn't always happen. Okay, and some things get hot a lot quicker, and so you can probably think, first of all, which one of these do you think will get hotter quicker? Which one would I hurt the most if I touched this with my hand or if I stuck my finger into there? Okay, if you've ever waited for water to boil to make noodles or something like that, spaghetti, what have you, then you know sometimes it seems like it takes a long time. All right, but if you stick a pot on the pan and don't put any oil or anything in it, it will get hot very quickly, and then when you put the oil in it, it will splatter all over the place. Okay, so we're going to kind of talk about why that is a little bit. Now, to let this experiment go, we're going to go a little bit, let these two pieces get a little hotter. Now, the problem is someone says, how do I take a thermometer like so? I can't stick it inside this piece of metal here, okay, and find the temperature of that piece of metal, all right, like I can stick it in the water and find its temperature. So the question is, how do we know how hot it is? Well, being science, there are formulas we could use to calculate exactly how hot the piece of metal is by knowing how much it weighs, and when we stick it in the water, how much it causes the temperature to go up and stuff like that. But we won't do that right now. We did that in physics, but we're not in physics, we're in anatomy. So here we go. So we're going to let these sit here. Now the water, we have some water over here, and it's about at 28 degrees Celsius. That's about 72 or so in Fahrenheit. And this one's about 29. So 28 or 29 degrees. They're pretty close to the same temperature of water. Okay? Now, neither one of these are probably exactly ready for me to touch them, okay? But if I stick my finger in this one, it's a little warmer than I would take a bath, but it's not that hot yet. You can see a few bubbles forming, but that's probably just oxygen that's been dissolved in the water coming out. It's not boiling or getting close to boiling yet, okay? All right. But let's let it sit just a little bit longer. I wish I had a pause button, but I don't know how to do the pause button, so we'll just go ahead and have to wait here a little bit. All right, so I'm going to take the water off this side. Sorry, I had it up front of there. And I'm going to pour it into this beaker here of 200 milliliters of water. And we will see the temperature goes up to about 45, give or take a little bit, 45 degrees Celsius, okay? Now we're going to take the metal, which has been on there roughly the same amount of time, okay? And we're going to put it in this water and see what happens to it. Ooh, notice that sizzle. Ooh, all right, the water didn't do that when we stuck it in there. All right, now let's just stir the water around that piece of metal so the heat from it will come in here. Okay, you notice we poured the water, it didn't make the heat, the water that was sitting there sizzle or boil or anything like that, but this one did, okay? Now we're gonna let it sit in there a little bit so all the heat from the metal can go out into the water. And it's gonna go in there, it's gonna be about 39 degrees. Now that one was about 44, okay? But roughly they had the same amount of heat energy, so they made the water go up the same. On the other hand though, had I tried to pick this up in my hand, I would have burned myself. Why? Because the temperature of it was a lot hotter than the same mass of water. And so if I stuck my finger in there, the temperature of the water did not go up as much. This is why you sit there boiling pasta. It seems like it takes forever. The saying that it takes, watch pot will not boil, is because it takes a long time for water to boil. And that characteristic has to do with its specific heat, which we will talk about in the anatomy lecture.